Hey, what's up, everyone? Hey, go ahead and give me a type in the chat box whether you can hear me or not. Um, if you can hear me, just give me a thumbs up, something like that, in the chat box. All right, cool. And then now, if you can actually see me, go ahead and give me a thumbs up in the chat box or something like that. If you can see me now. All right, cool beans. All right, so just mixing it up a little bit, just so you guys don't just have to listen to a voice the whole time. You can actually see my face, and I know you guys miss seeing my beautiful face, uh, quarantine beard and all, or wannabe quarantine beard, I guess. This is probably the only time I could actually even attempt to grow a beard without it looking like crazy patchy. So, hey, jumping right into this. Hope you guys are doing well. Trust everything's going good. Some other people had messaged me and let me know they might not be here today. So good to see you guys. Let's just jump in here to number 25 homework. So anything you guys have questions over, I'm glad to help with. Any questions off the top of your head, I can show you the answers right here. This is 1 through 8. Can make me a little bit smaller so it's not so I'm not as much in the picture. Here's 1 through 8. If you have any questions off the top of your head, feel free to just shoot them to me. So Alex says 24 and 27. So just to kind of go through here a little bit, just to go through here, number 1 is negative 9x plus c. Number 2 is negative 4x squared plus c. Number 3 is 6y plus y squared plus c. Number 4 is x to the 8th over 8 plus c. 5, x to the 5th over 5 plus x to the 4th over 4 minus x cubed over 3 plus c. 6, x cubed minus x to the 4th plus c. 7, x to the 6th over 9 minus 5 over 4 x squared plus x over 2 plus c. Number 8, negative 1 over x cubed plus c. Number 9, 2x plus 1 over 4 x to the 4th minus 7 over 2x squared plus c. 10, 10 over 3x to the 3 halves plus c. 11, 25 over 6 x to the 6 fifths plus c. Number 12, 4x to the 7th fourths over 7 minus 4x to the 1/4 plus c. 13, 18 over 6x to the 5/3 plus c. 14, x cubed over 3 minus 9x squared plus 81x plus c. Number 15, negative 8x to the 4th plus 48x cubed minus 108x squared plus 108x plus c. And 16 is right here, Timmy. 1/2 x minus 2 over x plus 1 over 4x squared plus c. So, Timmy, I started out but just by putting each of the numerators under the denominator 2x squared. Started out like that. Then I and then I simplified. The x cubed canceled there, just leave me 1/2. Here an x cancels with one of those x's, giving me 2x to the 2nd. But and then 4 over 2 is negative 2, and then when I bring that x to the 2nd up, it becomes negative 2. And then over here, can't mess with that. The only thing I can do is push the x to the negative 3 up. So I push the x to the negative 3 up over 2. And then from there, I would then integrate. So 1/2 x, add 1 there, that takes that to -1, put it over -1. That goes to -2, put it over -2. Simplify all that, you should get 1/2 x minus 2 over x plus 1 over 4x squared plus c. Cool, Timmy, very good. All right, 17, t squared over 7 plus 12t to the 5th over 5 plus 12t cubed plus c. 18 would be 18 over 5x to the 5 halves minus 8x to the 3 halves plus 8x to the 1 half plus c. Okay, that's the front side going to the back. Number 19 would be 3/7 sine x plus c. Number 20, 4x minus 8 sine x plus c. Number 21, -1 over x plus 10 cosine x plus c. Number 22, tangent t plus cotangent t plus c. 23, x plus c. Sine squared x plus cosine squared x, that's Pythagorean identity. So that just equals 1. And then obviously just x plus c there. 24, I actually split it up a little bit here. So I know that this whole 1 minus cosine squared x is actually equal to sine squared x, Pythagorean identity. And then the numerator stayed the same. But then I split it up into 3 problems. -4 over 1, cosine over sine, and 1 over sine, which is what, and 1 over sine x. The sine squared x can be split up into single sine x's. Then from there, -4, the derivative, I haven't taken the integral yet. I'm just kind of reworking the problem. The cosine over sine is cotangent, and 1 over sine is cosecant. And then that's all dx, and then you just take that. And actually, this right here is like on our chart. So it's negative cosecant, so the negative changes to a positive since the actual formula is a negative. So 4 cosecant x plus c. Okay, jumping down here, these 4 problems, I'm just going to get, you're just looking for the f of x. So f of x is equal to x squared plus 2x plus 5. F of x is equal to x cubed minus 7x plus 1. And again, you could pause this at any time if you want to go back, rework it, see my work. Over here, f of x is equal to -4 radical x plus 3x minus 4. And the last one over here, f of x is equal to negative cosine x plus 2x minus 2 minus 2 pi. And who was it? Alex? Alex wanted to see 24 and 27. Sorry. Alex, did that make sense on 24? Okay, so Alex looking at 27. So Alex, from the start here, I'm going to change that x to the, okay, cool. Now looking at 27. X to the 3 halves. If I push that up, it becomes x to the -3 halves. So I just want to integrate that. So increase it, okay? I probably did this somewhere on paper. So here is me working out this. It's 1 over x to the 3 halves is x to the negative 3 halves. When you add 1 to that, you get that to be negative 1 half over negative 1 half. Right? And then from there, if you flip that, 1 divided by negative 1 half would be negative 2. And then you just push this down. So that would be radical x. So 1 divided by negative 1 half, if you here right here is the work, 1 over 1 over 1 over 2, flip it up, 2 over 1, and it's negative 2, and then push that down, x, the square root of x. That's how I get this right here, and then I add that to C1. I then plug in a 4 for the x, because that's what it gives me, f, or I plug in a, what do I plug in there? Yeah, I plug in a 4, so I'll plug in a 4 there. That would be negative 2 over 2, which is negative 1 plus c to the 1. Set that equal to 2. Coming from that, c to the first is equal to 3. And then we plug that 3 in there. And now I'm just going to come over here and integrate that, or do the antiderivative of that. So this right here is negative 2x to the negative 1 half. So then again, bring the negative 2 out. And then you're going to raise that a power, so that should take that to 1 half over 1 half. 2 divided by 1 half is negative 4. And then you obviously have a radical, you have x to the 1 half in the numerator. So that's radical x plus 3x plus c squared, and then you just plug in from there. So Alex says it could also be negative 2 there. Where at, Alex? What line? Are we on the left side or the right side, and what line? Oh, okay, I see what you're saying. Yeah, I see what you're saying there. We're saying right here, you're saying that could be plus or minus 2. This actually situation came up the other day in another class, and most of the time, majority of the time, you're going to go with the positive number there. If you go back to think about those square root quizzes that we gave, if I gave you the square root of 4, you wouldn't say plus and minus 2. You would just say 2. So that is just kind of the general rule for that. Now, of course, you know, when you're dealing with that equation and it was x equals something, which I kind of know it's kind of a hard line to like cross, but most of the time you're going to go with the positive. But I would agree with you that it could also be negative 2 there, which may work for your function as well, because this is just one point of the function. Yeah? And then looking at the last one, if I don't see any other questions, looking at that last one, 29, should be 76. Give me 1 second, guys. All right, so our change, the population change, is given by this function. So we know that that is our derivative. The change is the derivative. So this is our derivative. So we just need to integrate that in order to get back to the original function. You integrate that, you should get negative t squared over 8 minus 2t plus c. Then we got to go find what c is. All right, it says if there were 100 cats in the year 2012. So technically speaking, if we put the population P as 100 here, okay, T represents time. Well, when it was 100 cats, no time had passed. So this is like kind of like the initial value. So like 0, 100. So when y is 100, x would be 0. So plug a 0 in and you find C to be 100. And then we have P is equal to negative t squared over 8 minus 2t plus 100. Then we plug how many cats would be there in 2020. You plug 8 in there, and you should get to the number 76. Any other questions on the homework? Give me a thumbs up or a question in the chat box. Thumbs up, I'm ready to move on. Question if you have a question. All right, Ian's good. Ben's good. Alex is good. Colton's good. Cool, cool. All right, so let's pull out that 26 classwork, guys. Pull out 26 classwork. Should be looking something like this. Give me a thumbs up. Give me a thumbs up if you have that in the chat box. Or I'm good, whatever it is you want to say. All right, Colton's good. Timmy's good. Ian's good. Ben's good. Carter's still with us? Alex is good. Not sure if Carter's still with us or not. Okay, so here we go. 26 is U-Substitution. All right, so if you were asked to take the derivative of f of x equals x squared minus 1 squared, you could either multiply the expression out and then use the power rule, or you could just use the chain rule. With f of x equals x squared minus 1 to the 5th power, the chain rule is far superior, and for f of x equals x, the square root of x squared minus 1, the chain rule is necessary. We will find the same argument is true for integration. So to find the antiderivative of x times the quantity of x squared minus 1 squared dx, we can multiply it out and get x to the 5th minus 2x cubed plus x dx. Then our answer would be x to the 6th over 6 minus x to the 4th over 2 plus x squared over 2 plus c. But to find the antiderivative of x times x squared minus 1 to the 5th of dx, multiplying it out is clearly not a good option. Okay, you would have to do a trinomial times a binomial, and then a trinomial times a trinomial, and then a 4-term polynomial times a trinomial. A lot of room for error. So not a good option here. So we must use a method called U-Substitution. This method is a bit tricky, like the chain rule, and like the chain rule for differentiation, it takes some getting used to. But I think you guys can handle this very quickly. I really do think you guys can get it. Okay, so starting with, here we go. The first step we want to do is we will define an expression called U. which is usually the expression in the parentheses. 99% of the time, it's going to be the expression in the parentheses. So I have this right here. I'm just pulling this from this right here. So x times x squared minus 1 squared dx. Okay, so it says the first thing we need to do is to define an expression called u, which is usually, sorry, I can't speak, is the expression in the parentheses. So right here is my parentheses. So we're going to say u is equal to x squared minus 1. That's our first step. So that's step 1. Our second step is then to find du of d with respect to dx and multiply both sides by dx. So find du of dx. Someone type that in the chat box. What is the derivative of u with respect to x? What's du of dx? Good, Alex. 2x. So just basically taking the derivative of u. That's what this is saying. What's the derivative of u with respect to x? Okay. And then, so that's the second step. Then we'll now find du. So this is the second step, and then continue on from there. We want to isolate du. So we want to get this alone. So I'm going to multiply both sides by dx times dx here. And I get du is equal to 2x dx. Okay. So it says we will now rewrite this right here, our antiderivative, in terms of u. To do this, we need to manufacture a 2x dx. We have an x dx, but we need a 2. So we multiply our integral by 2 on the inside and by 1/2 on the outside. Okay. Now this is where it gets a little bit foggy, but hopefully I can. This is in words. It's a little bit harder than what it actually is. Okay. So here is what I would do first. So here we have our derivative, or excuse me, our antiderivative, x times x squared minus 1 squared dx. So we're wanting to rewrite this in terms of u. Okay? So basically, I don't want any x's and I just want u's. All right? So here's what this is saying. In order to change this dx right here to a du, I need to have 2x and 2x dx in the problem. Right now, the only thing that I have is x dx. Well, x dx is not equal to du. So I need to get a 2 right here. Okay? I need to put a 2 in front of that x. All right? Well, the only way to do that, okay, is to multiply the other side by 1/2. Okay? And that's where it says we will multiply the integral by 2 on the inside and 1/2 by on the other side. And that's just kind of balancing the integral, what we would call it. All right? So here's what that looks like. 1/2 integral. Now I'm going to put a 2x here. put a 2 there. And then I have x squared minus 1 squared dx. So, whatever you multiply this side, the right side, or what we would call the inside of an integral by, you have to multiply the other side by its reciprocal. So if we multiply this side by 3, we're going to have to multiply this side by 1/3. And that's just the rules of integrals. Okay? So now pay attention and watch this. So now I have 2x and I have dx. Okay? Now up here, that is what du is. Du is 2x times dx. And you all know that we could rearrange all this to get 2x and dx together. But we also know this, that x squared minus 1 is right here, and that is u. So when I rewrite this in terms of u, this is what it looks like. 1/2 integral. Now watch this. I'm going to deal with this 2x. I'm kind of like putting that 2x down there on the end. But x squared minus 1 is u. So we're going to say u squared. And then the 2x dx changes to du. All right, again, just to explain that, 1/2 stays here, integral, but x squared minus 1 is u, so we're going to replace that with u and put it in it's still going to be squared times du. Now remember, this du is just like this dx up here, okay? It really is just the bookend. Remember how I said these two are the bookend? It's what you're solving it in terms of. Here we're solving it in terms of x. But here we're solving it in terms of u here, okay? So really now this acts as a bookend, and obviously this right here would be the bookend. So I'm going to do the integral of u squared. So here's what that looks like here, guys. So this is all equal to, I can't really go down, so I'm going to go to the right here. This is equal to this. 1/2 times, that's that 1/2, times the antiderivative of this right here, which you all should know would be u cubed over 3. And again, you don't have to worry about the du. The du is just what we're solving it for, so it just kind of disappears, just like dx would always disappear if we were solving another antiderivative. Okay? So then that takes us to this. And I'm sorry, guys. Hey, let's make a quick change real quick because I just saw an error that I made. But it won't make any difference just with 2 numbers. So this is actually right here. That's actually to the 5th power. So let's change that to the 5th. Sorry. Again, it won't change anything just until the end. So u to the 5th, and that it makes sense why it'd be to the 5th. So then that would be to the 5th. That would be to the 5th. This would be to the 5th. So then that would change that to u to the 6 over 6. I was looking at my answer and I thought, man, that was way off. Okay, sorry I copied the problem down wrong. So it meant to be 5. So it just changes all that to 5. Doesn't change anything until we get to the integral part. Okay, so then here, that's u to the 6 over 12. And then your last step, okay, so our third step was rewriting it in terms of u, which is about right here. We rewrote it in terms of u. And then the 4th step was here, doing the integral. So that's 3rd step, 4th step, and then the fifth step would be to plug u back in. So plug u back in. So that would be, I'm just going to write it down here, x to the x squared, I'm sorry, that would still be a 2 there, x squared minus 1, because that's what u is x squared minus 1. The 5 was on the outside. To the 6th power all over 12. And then don't forget about your plus c. Yeah? So not too bad. Just need some practice with it, and then we'll get it going. We'll jump into it real good. And I just got to make sure I write down the correct problem. So that'll help too. So it doesn't seem like we're fumbling everything. All right? So this process might seem cumbersome, but you'll get used to it. Do not try to do all the work in your head. It is important to show your u and du. I also do it on the right side, and the left side uses the substitutions. When you try and create your du, you may multiply integral inside and outside by a constant, but never an expression using a variable. Here's a highlighter. Oh. So I'm going to highlight that right there. So you may multiply the integral inside and outside by a constant, but never an expression with a variable. So notice how we multiplied this right here. We just multiplied it by 2. So multiplying it by 2 is fine, but you cannot ever multiply it by something other than a constant. What's up, Ann? All right. So you do not have to add on the constant of integration until the very last step. It is suggested to students that they take the time to take the derivative of the answer to check their work. So if we took the derivative of this low d high minus high d low over low low, it would take us back to our answer that we did up here. Okay. For time's sake, you can trust me on that, but on your homework, you may want to, maybe your first or second one, maybe take the derivative of it just to make sure you're on the right track. All right, so let's look at number 1. All right, the only way to get good at it is to practice it. All right, and it's not as bad as what the first problem seems. You guys will kind of get into the hang of it pretty quick. So, looking at number 1, all right, it's saying what is the antiderivative of 3x minus 2 to the 4th power dx? Now again, you could multiply this out. You'd have a trinomial times a trinomial, and then you could then do all that. That's a ton of work, and some of you may say, well, I can handle that pretty easy. Just understand there's a lot of room for error there, so that's why I would, again, I'm not, you guys know I'm not that teacher who's going to say, hey, you got to do it my way, but I would encourage you to do U-sub here, okay? So let's go. So first thing we do is identify u. U is 99% of the time it's in the parentheses. So I'm going to say u is equal to 3x minus 2. Very first step, identify u. Most of the time it's going to be inside the parenthesis. Next, find the derivative of u. Well, that would be here. That would just simply be 3. Then multiply both sides by dx, cancels, cancels, and du is equal to 3 dx. Give me a thumbs up if you're following me on this. Just give me a thumbs up. Hey, I'm with you on this. I'm kind of seeing this the way it works. Colton's good. Carter's good. Just this part, guys. We're not talking about the grand scheme of things. I'm not asking you to go from here. Timmy's good. Ben's good. Okay, Alex is good. All right, so now from here, what we want to do is we want to say, okay, I need this inside here. I need to have a 3 next to that dx in order to represent it in terms of u. Okay? So I basically need this right here to be on the right side here. So what I'm going to do is I'm going to multiply the right side by 3, which means I'm going to, or the inside of the integral by 3, which means I multiply the outside by its reciprocal, 1/3. So it should look like this. 1/3 integral 3 times 3x minus 2 to the 4th dx. From here, I'm now going to write it in terms of u. Okay? So 1/3 integral 3 times dx is du. Okay? So we're going to handle that at the end. But this right here, 3x minus 2, which is u. So we'll say that is u to the 4th. So u to the 4th du. Again, the du came from the 3 times the dx. We put the 3 in there in order for that to happen. Now we're just solving it in terms of u here. So then you just integrate the inside. So that's 1/3 times u to the 5th over 5. That would be equal to u to the 5th over 15. And then we just replace u. Okay, then we just replace u and add the c. So that would be u is 3x minus 2 to the 5th power over 15 plus c. And that's what we're looking for, guys. Questions in the chat box over number 1. Just give me yes or no. Yes, I have a question. No, I'm good. Okay, cool. All right, looking at number 2. So I'm going to rewrite the integral first, okay? So rewrite the integral, and we're going to say 5x plus 4 to the 1/2. Now, we don't know what of course we know that's a square root, okay? But we really wouldn't know how to simplify this out, okay? So in that case, we use U-Substitution, all right? So here we go. Identify what u is. U is 5x plus 4. Then identify our derivative. Du of dx is equal to 5. Multiply both sides by dx. We find du to be 5 dx. Basically, we just got to add a dx there and just say du equals that. Okay? Now, so guys, this is where you got to put. I think if there's any confusing part, this may be the one confusing part, is to say, okay, the only way to get this in terms, solving it in terms of u, is to get this right here, okay, being multiplied by 5 here, so I can change it to du. And then it basically just falls off because it says I'm just solving it for terms of u. Okay? So I'm going to, so I already have a dx in the on the inside of the integral, so now I just need a 5. But in order to put a 5 right here, or on the end, either one, I need to multiply the outside times the reciprocal. So I'm going to say 1/5 antiderivative of 5 times 5x plus 4 to the 1/2 dx. I want you to tap in the chat box if you're good on that concept right there. That is the hardest concept. If you get that, you're good. Any questions on why we're multiplying by 5? Yes or no in the chat box. Alex is good. Colton's good. Carter, Ben, good. Ian's good. Timmy's still with us? Good. All right. So from here, we then we just replace all x's with u's. Okay? So here we go. 1/5 antiderivative of 5x plus 4 is u, guys. So we're going to say u to the 1/2, and then 5 times dx is du. So then we just say du. All right. Then from there, we just integrate the right side. So that would be 1/5 times, that would go u. You add 1 to 1/2, which goes to 3/2. And then we put that as the denominator as well. Okay? So 1/5 times 1 over this right here, okay? That would take that would be 1 over 5 times 1 over 3 over 2. And that would actually take that to 1 over 15 over 2. And if you remember, we just flipped this up. So it should be 2 over 15, okay? So if that was like 1 over 1, you just flip it up and say 2 over 15 and multiply, and that would be our answer, 2/15. So it's going to be equal to 2's in the numerator, but this is in the numerator as well. This whole u to the 3/2, and I'm going to go ahead and plug in u. So 2 times 5x plus 4. I just plug u back in, raise it to that power, and I put this all over this right here, which would be 15. So that's my 2/15, and then that's in the numerator as well. And then I always say plus c with any antiderivative. Okay? So that right there is our answer. Actually, wrong. That one right there is our answer. So any questions on that? Give me thumbs up, or hey, I got a question on number 2. All right, cool beans all the way around. All right, so jump over here to number 3. All right. So let's look at 3. So looking at number 3, it says the antiderivative of 4 times the quantity of 6x minus 1 raised to the 2/3 dx. All right. So when I'm looking at this, first step, I don't need to rewrite anything. So first step is just identify what u is. U is equal to 6x minus 1. Okay? Du of dx is equal to 6. So du is equal to 6 dx. Okay, so notice here, I have the dx. The dx is taken care of, okay? But here I have a 4 and not a 6, okay? So that presents a little bit of a problem because I need that 4 to be a 6. So I ask myself, what times 4 will give me 6? Or 4x equals 6. 4 times what equals 6. Divide both sides by 4, and you'd see that x equals 3/2. So that tells me this. And if so just the proof is in the pudding. So if I say 4 times 3/2, 3 divided by 2, we get 6. Okay? So 4 times 3/2 is 6. So that just kind of proves it there. So if we multiply the inside by 3/2, that means we have to multiply the outside by what? Someone type it in the chat box. What would I multiply the outside by? Good, Timmy. 2/3. Good, Alex. So 2 over 3 integral, and then watch, that changes automatically to 6. That 4 changes to 6 because I'm saying 4 times 3/2, which is 6, times 6x minus 1 to the 2/3 power dx. From there, we say 2/3. We put it in terms of u. So 2/3 integral, the 6 times dx will go to our du here. And then this would just become u to the 2/3. Inside is u to the 2/3. And then we just say du. From there, I'm ready to integrate here. So 2 over 3, and then times, that would be u to the 5/3 over 5/3. Get a little bit closer for you guys. Maybe that'll help you all. Sorry, that's my dog. Sounds like he's choking on the water. Hey, easy. All right, so from there, 3, and you can think about, you just multiply fractions at the denominator. 3 times 5 is 15. 15 divided by 3 is 5. So this should be equal to 2. U is 6x minus 1 to the 5/3 all over 5. Because 3 times 5 is 15, divided by 3 is 5. And then just don't forget about your plus c. All right, moving right along, number 4. So looking at number 4. First step, I'm going to rewrite it. Okay, first step, I'm going to rewrite the integral to be x times x squared minus 2 to the 1/2 power. All right. Then I see that my u will be equal to x squared minus 2. So then my du of dx is equal to 2x. Therefore, my du is equal to 2x dx. All right, if my du is 2x, and this is what I have right here, what do I need to multiply the inside by in order to use the U-substitution? What should I multiply the inside by? Good, Timmy, a 2. Good, Ian, 2. Because I have 2x here in dx, well, here's the dx, here's an x, so I just need to multiply this side by 2. So that means I multiply the left side by the reciprocal. So 1/2 antiderivative of 2x, x squared minus 2 to the 1/2 dx. From there, we put all terms in terms of u. So we say 1/2 integral u to the 1/2 du. The 2x and the dx become du, and that's just kind of like a bookend for the integral, saying we're going to integrate this. From there, I have 1/2 times u to the 3/2 over 3/2. That would be u to the 3/2 over 2 times 3 is 6. 6 divided by 2 is 3. And then I just plug what I have in. X squared minus 2 to the 3/2 over 3 plus c. Okay, look at number 5. Moving on to number 5. So look at number 5. I'm going to rewrite it. X squared, and then I got quantity of 1 minus 4x cubed to the 1/2 power. So then that tells me my u is always the inside of the parentheses, so 1 minus 4x cubed. I take the derivative of that, du of dx, and that is negative 12x squared. So du is equal to negative 12 x squared dx. So what do I multiply the, so I got x squared and I have dx. So what do I need to multiply the inside of the integral by in order to set up the U-substitution? Good, Ian, negative 12. So if I'm going to multiply the inside by negative 12, I'm going to multiply the outside times the reciprocal of that. So that would be negative 1/12 integral. And then that would just be 12x squared, or negative 12x squared, excuse me. Negative 12x squared times 1 minus 4x cubed to the 1/2 dx. From there, we can just set up our U-substitution. So that'd be negative 1/12 integral negative 12x squared and dx. Just change to du, and this changes to u to the 1/2 du. So negative 1/12 times u to the 3/2 over 3/2 is equal to, so this should be negative. Let's go ahead and take care of our, this down here. We can see 12 times 3 is 36. 36 divided by 2, 36 divided by 2 is 18. So 18 is on the bottom. I'm going to go ahead and substitute our u in. So that is 1 minus 4x cubed. And that is all to the 3/2 power. And then we just add c to it. All right. Moving right along, guys. Going to number 6. So looking at number 6, here we go. Number 6 should look something like this. So let's change this up right here. I think most of you guys can handle this. So going from this to the integral of x times 2x squared minus 1 to the negative 1/3. And that would be dx. So again, that's just changing 2x squared minus 1 to the 1/3 on the bottom and then just moving it to the top by making the exponent negative. I then see that my u is going to be 2x squared minus 1, making du 4x, du with respect to dx there, and then du would then equal 4x dx by multiplying both sides by dx there. So I have an x, so I just need to multiply this side by 4 in order to make that a 4x dx to get that in terms of u. So if I multiply the right side by 4, I'm going to have to multiply the outside by 1/4. 1/4 antiderivative of 4x, 2x squared minus 1 to the negative 1/3 dx. And then I can put everything in terms of u. So 1/4. That would be u to the negative 1/3 du, because 4x dx is du, so we just put du there. Okay, then from there I got 1/4 is, or times u to the, if I add 3 to that there, 3/3 to that, that should take me to 2/3 over 2/3. 2/3 over 2/3. Okay. And then if you think 4 times 2 is 8. 8/3, so 1/8/3, we're just going to flip it up. So that should be 3. And then u is 2x squared minus 1 to the 2/3 all over the 8. Again, if you just say 1/4 divide, or I just said 4 times 2 is 8. 8 divided by 3, and then 1/8/3 is 3/8. So then 3 just be 3/8 u to the 2/3, which would represent this right here. And then we just need to add it to c. All right, let's keep chugging along, guys. Looking at number 7. So we have x to the 1/2 and x to the 3/2 plus 4 to the 9th power. Okay. So my u is 99% of the time it's in the parentheses. So I got u is equal to x to the 3/2 plus 4. So du of dx is equal to 3/2, 3/2x, and then think about adding that to, adding 1 to that, since we're taking the, we subtract 1. Woo, 2/2. We subtract 1 since we're taking the derivative. So that's 1/2, 3/2 x to the 1/2. And then du would be 3/2 x to the 1/2 plus c. Okay. So over here we have x to the 1/2. I have an x to the, or I said plus c, I meant dx. Sorry. Trying to get finished. So x to the 1/2 here, dx is there. I just don't have a 3/2 here. So I need to multiply the inside of the integral by 3/2 and multiply the outside by the reciprocal, which would be 2/3. So 2/3 antiderivative, 2/3 antiderivative of 3/2 x to the 1/2 times x to the 3/2 plus 4 to the 9th power dx. Okay, so then from there, we would have 2/3. The 3/2 x to the 1/2 and dx is du. So then it would just be this 2/3 integral u to the 9th du. From there, 2/3 times u to the 10th over 10. Well, think about that. That's going to be 3 times, so that'd be 30. 3 times 10 is 30. And then 2 over 30 would be 1 over 15. So my denominator is going to be 15. And the numerator would be 1/15, right? 1/15 there. So it's just u, whatever u is, x to the 3/2 plus 4 to the 10th power. And then just plus c. Okay, look at number 8. X plus 2 over x times the square root of x squared plus 4x minus 5. Now, I think it would be natural for us to jump on the bandwagon and say, hey, whatever's in the parentheses is my answer. So let's take a look at that. So if we said that u was equal to x plus 2, and then du of dx would then be 1, right? That, and then, of course, du would then be just dx. So we have a dx, right? And this is representing my u here, okay? Then I would have to multiply, I would have to multiply everything. I'd have to do this right here, okay? X squared plus 4x minus 5, okay? I would have to multiply this whole side times that, which is happening, but then I'd have to multiply the left side times 1 over that, the reciprocal. And then I'd have to multiply all that at the end. So, while that is possible, okay, while it is possible, always, if you have more than one parentheses, just look at both of them, okay? So that's that one, and that just seems like it could potentially reach a headache. But then let's go ahead and write it the other way. And let's say, let's write it as the integral of x plus 2 times x squared plus 4x minus 5 to the 1/2. Okay? So, again, this way right here is showing you if you use this parentheses. So we hadn't had one yet that has multiple parentheses. So you want to use the one that is easier on you, okay? And you may say, hey, how can I tell which one's easier for me? Well, just make them both u, see what the derivatives look like, and see what you'd have to multiply by, okay? So this is using x plus 2. But what if we made u the x squared plus 4x minus 5? So then du of dx would then be 2x plus 4. Okay? And then I know what some of you are thinking. You're like, well, hold on. 2x plus 4 doesn't really match up with this x plus 2 either. So which one would be better for me? But always remember, we could factor this. Okay, what happens when we factor it? We get 2 times x plus 2. Now look at that. I have an x plus 2 and I have an x plus 2. So du would be 2x plus 2 dx. So I have the option of multiplying, if I go with this u, by multiplying the left side by 1 over x squared plus 4x minus 5. Or if I go with this as my u, I just multiply this side by 2 and that side times 1/2. I hope you're seeing kind of the way to decipher which parenthesis do I use. I use the one that's going to make it easier on me. So sometimes you have to check both. Okay? So obviously with our work there, we kind of see that the other one's better. So with that, let's just say u is equal to x squared plus 4x minus 5. And we'll take our derivative from there. And that's 2x plus 4. As I said, we can factor a 2 out, leaving me that dx, and that would be my du. Okay, so I have a x plus 2, and I have dx right here. So that can take care of that in terms of u. But I need to multiply it by 2 in order to make this whole thing in order to make this and this a du. And of course, we know this is u. So I need to multiply the left side by 1/2, multiply the inside of the integral by 2. 2x plus 2, x squared plus 4x minus 5 to the 1/2 power. And that's, of course, still dx. All right, so from there, I got 1/2, 2 times x plus 2, and dx is my du, and then I just say u to the 1/2 times du. All right, guys, so from there, I'm just going to say 1/2, and then I say times u to the, add 2 to that numerator, 3/2 over 3/2. That would take me to u to the 3/2 over 2 times 3 is 6. 6 divided by 2 is 3. I rewrite it with the un. X squared plus 4x minus 5 to the 3/2 power all over 3. And then we just add c. All right, hope this is making a little bit of sense to you guys. Trucking right along. The number 9, the integral of x minus radical 3x dx. Okay, so looking at that. So now this actually presents something a little bit interesting. Okay, now this is a subtraction integral. Okay, so if you went back to our, let me see if I have one nearby. So if you go back to our integration formulas, notice here it says that when you have f of x plus g of x, d of x, that you can break those down into an addition or subtraction problem, and you just take you just integrate both sides separately. Okay, so looking at this, I think that is what's best to do here, because if you think about it, there's a parenthesis within the parenthesis here. Okay, so the way I'm working this problem is to say this: the integral of x, okay, if I'm just rewriting it, minus 3x to the 1/2 dx. So I would start off by writing it like that, okay? And since this right here is subtraction, everything else we've done at that second step has been multiplication, okay? So we've been multiplying, but here we have subtraction. So that's where I'm saying let's integrate the left side, so x dx, and let's integrate the right side, so minus the integral of what we have here, 3x to the 1/2 dx. Okay, so this left side comes out looking pretty smooth, just x squared over 2 minus, now this right here, this 3x to the 1/2. Now we could say x to the 1/2 and we could handle that. 3 to the 1/2 is a decimal, so that gets a little bit nasty. So let's actually use the U-substitution just on this right side. So u is equal to 3x. My derivative of u is equal to 3. And therefore du is equal to 3 dx. Okay? So then if I have a dx here and a dx here, I just need to multiply this times 3, okay, in order to get that in terms of u. So I would have x squared over 2 minus, now don't forget, when you multiply on the inside, you need to multiply by its reciprocal on the outside. So that would be 1 over 3 integral 3 times 3x to the 1/2 dx. All right, then from there, we're going to say this. X squared over 2 can drop, minus, now let's substitute u here. So 1/3, and then that, of course, will be times u to the 1/2 times u to the 1/2 du. Technically speaking, that's still an integral. Now we integrate x squared over 2 minus 1/3 times, that's u to the 1/2 over 3 over 2. Okay? So then from there, now I'm not going to mess with this right here. I'm just going to keep that. I'm not worried about getting the like denominators or anything like that. So let's just clean this right here up. So my answer would be x squared over 2. And I know it's going to be a minus because this times this. And that should come out to be 3 times 3 is 9. 9 over 2. 1 over 9 over 2 is 2/9. So it should be x squared over 2 minus 2. And then don't forget about your u to the 1/2. U is 3x. 3x to the 1/2 all over should just be 9. And I actually forgot, I'm surprised one of you guys didn't mention, this u to the 1/2, you all should know, that should have been a 3 there. I had it right in the denominator, just I forgot to do it there. So 3/2, so that would be just 3/2 there. I did it right here, so all the rest was correct. I just didn't do the top one correct. So change that to 3/2, and then from there we're good. X squared over 2 minus 2, and then just don't forget about plus c. All right, look at number 10. So the integral of the square root of x squared minus 1 dx. So looking at this, I'm going to rewrite it as x squared minus 1 to the 1/2 dx. So then use the inside. U is equal to x squared minus 1. So then du of dx is equal to 2x. And therefore du is equal to 2x dx. Okay, now I have the dx here. I don't have anything here, okay? So I multiply this side by 2x and this side by 1 over 2x. Can I do that? Yes or no in the chat box. Can I do that? Can I multiply this side by 2x and this side by 1 over 2x? Maybe no one knows. Ian says not sure. Okay, cool. So just take you to this highlighted portion. You may multiply your integral inside and outside by a constant, but never an expression using a variable. Okay? I did a little test with you on that on problem 8 just to see if some of you would catch it, but I guess no one did. So thinking about this problem right here, okay? When I did u times 2, well, actually that one would have it would have been fine on that one, okay? But technically speaking, we couldn't have multiplied this side. You can't ever multiply anything but a constant, okay? So getting here, I cannot multiply this side by 2x and this side by 1 over 2x. So this cannot be solved using antiderivative rules. Or U-Substitution. So you will not see one like that on the AP exam. So that would be a later course where you would kind of learn how to do something like that when U-Substitution and your antiderivative rules would not work. Okay? Hey, let's take a quick 5-minute break. We've been going for about an hour and 20 minutes. So let's take a quick 5-minute break. Go, use the restroom, get a drink, something like that. Come back here at 2:28. Okay? Come back here at 2:28. Hey, Ian, 91% of students surveyed about the AP exam, 91% said they still wanted it no matter what. So I think it's college, and keep in mind, College Board is a money-making business. So I'm pretty sure they're gonna have it. It may not be May 5th for AP Calc, but they could cancel it altogether. But they are a money-making machine, and students still want it. And technically, you've worked 7-8 months for it. The last two have been, last 2 months or so has been, or month and a half really before your AP exam has been online. So I would be shocked if they cancel it altogether. But from everything I read, they're coming out with something on April 3rd that will kind of give guidelines to kind of everything. So, but just a thought. I'm going to teach you like you're still taking a 3-hour and 15-minute test. That's my job, so that's what I'm going to do. All right, return here at 2:28. All right, guys, here we go. Getting going. All right, looking at, oh, Ian said I read that. I just don't know. I just don't know how it's going to work since they're already saying if we're on schedule to graduate by third quarter, we will. Oh, okay. I haven't, again, I haven't heard too much in the communication side of, I haven't heard too much of the communication side of the school. All teachers have a meeting tomorrow afternoon, and I assume we're going to hear some information then. So, not sure what that's going to look like. Again, I think they probably communicate with you all better than they communicate with the teachers. So, you all would probably know more about that than me. So, all right, let's close up. Last 8 problems. Give me a thumbs up if you're here. Give me a thumbs up if you're here. Colton's here. Carter's here. Ben's here. Ian's here. Timmy, you still with us? Cool. All right, here we go. Finishing this up. Shouldn't take too long. All right. So number 11, cosine of 4x dx. All right. So, hey, Alex, glad to see you're here too. All right. So, looking at this, it wants the antiderivative of cosine of 4x. All right. So think about 4x being our u. So think about this kind of like being in parentheses. It's the angle, right? So say u is equal to 4x. So then du of dx is equal to 4. So therefore du is equal to 4 dx. And we know that cosine is attached to this whole 4x here, okay? So we're not trying to eliminate cosine. All right. So in order to make dx go to du, we need a 4 as well, guys. So what we need to do is multiply the left side by 1/4, integral 4 cosine of 4x dx. So cosine will stay, okay? Cosine will stay even when we substitute the u. So then that's 1/4, okay? 1/4, and then 4 dx is my du, and then so that's just 4 integral cosine of u, okay, and then du. All right. So from there, we say 1/4 times, and then cosine. If you remember if you have your clock out, or you know your clock, I'll try to find it. I have it around here, somewhere around here. I thought I had it somewhere around here. Oh, there we go. Yeah, so if you have your clock here, okay, and if you were at cosine, remember on your clock you go the opposite way. So if we're at cosine, we just go to sine. And going the other way is the derivatives, okay? So that would be times sine u, okay? And then all of that would just simply equal sine u is 4x, so sine of 4x over 4 plus c. Okay, jumping to this next one. should be pretty obvious. Our u is the parentheses 1 minus 3x. So then therefore my derivative of u is equal to negative 3. And then my d, that's du of dx. So then therefore my du is equal to negative 3 dx. So I have a 3 here, and I have dx. I just don't have it negative. So I need to just multiply the right side or the inside of the integral by negative 1. And the reciprocal of negative 1 is negative 1. So it would be negative 1 over here on the right side times negative 3 sine of 1 minus 3x dx. Think of sine as kind of like the x, like the u, like the squared part. It's the operation that's happening to u, okay? All right, then from there I just say negative integral. Negative 3 in dx is du, and then we just say sine of u du. Then from there, so we're at sine, and we need to go antiderivative, so go counterclockwise, so negative cosine. So negative times the negative cosine of u, and then that should take us to positive cosine of 1 minus 3x. Negative times the negative is a positive, and then just substitute our u back in. And don't forget about plus c. Always plus c. All right, then looking at number 13, the antiderivative of sine cubed x cosine x. So here, let's rewrite sine cubed x as sine x cubed times cosine x dx. Okay? So I'm going to treat, the parentheses as my u, so u is equal to sine x. Now again, you go back to your circle. The derivative of sine is cosine. Okay, so du of dx would be cosine x. And then that would take us to du, which is cosine x dx. So notice here that our du is this dx right here. So then we don't have to multiply anything. So then that's just u cubed du, which is u to the 4th over 4, right? And then that's just equal to, plug the u in, sine x to the 4th over 4 plus c. (14) Antiderivative of cosine x times the quantity of 1 minus sine x dx. So I'm going to rewrite that in exponential form. So cosine of x and then times 1 minus sine x to the 1/2 power dx. So I'm going to treat my u as equal to 1 minus sine x. So then du of dx, the derivative of sine is cosine, but with that negative there, it's going to be negative cosine x. So then du is equal to negative cosine x dx. So U-substitution, I need this to cancel with cosine x and dx. The only thing I don't have is a negative, so I just need to multiply the right and the left by negative. So negative integral of negative cosine x times 1 minus sine x to the 1/2 dx. I feel like I may be going a little fast. I may slow down just a little bit. Okay, then from there, that would be negative integral negative cosine x, and dx is du. So then that's just u to the 1/2 du. From there, negative the integral of this would be times u to the 1/2 over 1/2. And then from there we, man, I keep doing that. It's 3/2. You got to add one. Sorry. So add one here. So add 2 over 2. And that's 3/2 and 3/2. So that would go to negative 2. Thank you, Carter. Negative 2 over 3. And then I know that's u here. Okay. And that u is 1 minus sine x to the 3/2. And make sure we always say plus c. Okay, moving right along. Number 15. So we have tangent of 10x, secant 10x, dx. Okay, so I'm going to say here, I'm going to treat my u as the 10x. Okay, so because obviously we write that as 10x. So u is equal to 10x, which would make du of dx equal to 10. And then du is equal to 10 dx. Okay, so I have a dx here, but in order to get that dx off and solve in terms of u here, I'm going to multiply the left side by 1/10, the right side by 10. So I have 1/10 antiderivative of 10 tangent 10x secant 10x dx. So I got 1/10 derivative. 10 and dx goes to du, and then that would just be tangent of u, substitute u in, secant of u, and then du. So then that would go to 1/10, and then the antiderivative of tangent x secant x, if you were to look on your sheet, it's actually just simply secant x. So times secant of u, right? And then that would just simply take us to secant, the u, plug it back in, of 10x over 10 plus c. Again, this is just a formula coming from the formula sheet. All right, looking at number 16. The antiderivative of tangent squared x, secant squared x, dx. So I'm going to write the tangent. So let's write it like tangent x squared secant squared x dx. Now, this goes back to one of those questions. Which one do I put in parentheses? Well, totally up to you, okay, which one you put in parentheses. But again, you can use both of them and then see which one is easier. I know already that tangent, the derivative of tangent, is secant squared x. So if I make u tangent, and that's just kind of knowing your derivatives. So if I make u tangent x, and then the derivative of u with respect to x would be secant squared x. So then that makes d with respect to u as secant squared x dx, which sets me up perfect here. You could go the other route, and obviously you can see what I have to multiply to get that. I'm not sure if it would work or not, but you can always try it if you wanted to. So, since this is secant squared x, I just got to multiply both sides by 1, which changes nothing. So then I can just say u squared du. Secant squared x dx is du, so du is here, u squared's here. So then I take the integral, that should be u cubed over 3. And u is actually equal to tangent x, so tangent x cubed over 3, and then plus c. Just plugging it back in, adding plus c, and we're good. All right. How do we feel about all of that, guys? We feel pretty good about it? Give me a thumbs up. You're still with me? Alex is good. Colton's good. Carter's good. Cool. Good. Okay, cool. All right, last two problems, then we're done for the day, guys. Sometimes it appears that integrals cannot be taken with U-substitution, but with a little creativity, they can be. If one choice of u doesn't work, try another. So we've kind of talked about this a little bit in even with number 16. Well, you could try both of them and see which one would work. So same thing here. Do I go with u as x plus 2 or do I go with u as x minus 4? Okay. Which one do I go with for that? Okay. So for this is actually a pretty interesting problem. Let me get a sheet of paper here. So let's say that I go with u being x minus 2. Or excuse me, x plus 2. For this problem, u is x plus 2. So the derivative of u with respect to x is equal to 1. Therefore, du is equal to 1 dx. Or we could literally say that du is equal to dx, really. Okay? So, I would have to multiply, if x plus 2 is my u, I would need to multiply this right here times the reciprocal of x minus 4, which I can't do because it has a variable with it, and I can only multiply integrals right and left by constant. All right, so let's look at the other one. What if we made u equal to x minus 4 to the 1/2? Well, that would make du of dx. That would make it what? 1/2 x minus 4. And then just times 1. And as we would see there, du would be then equal to 1/2 x minus, or 1/2 times 4 is 8, right? 0.5 times 4 is, oh no, it's 2. Man, I don't know what I was thinking. I was thinking dividing. So minus 2 and then dx. Okay? So with both of these right here, they both look pretty nasty in making you this, because I'd have to say, well, what do I multiply this by to get it to that? So these are both pretty nasty, all right? But the instruction says, but with a little creativity, you can, okay? So here's what I want us to think about. And actually, guys, man, you guys should have stopped me. This is wrong. Sorry. I knew that looked weird. It would just be the inside, x minus 4. So then u would be 1, and then du of dx would be 1, and then du is equal to dx. Sorry about that. I was like, man, something looks funky here. I accidentally brought the 1/2 with it. It's just the inside. Sorry. That's what I get for trying to take a step ahead. All right, so it's actually x minus 4. So they both actually equal. Du is both equal to dx. Give me a thumbs up. You're cool on that. Sorry, that was my mistake. You understand what I did there, my mistake, all that. You all are with me. Give me a thumbs up if you're with me. All right, cool. Sorry about that. So, with this both equaling this, since du is equal to dx, technically speaking, I can replace du with dx right here. Okay? I can replace du with dx right here, which would then replace the x's with whatever they are with respect to u. Okay? Well, if I look at this one right here, okay, let's go with this one right here. If I plug that in there, let's see what u is with respect to x. So basically go find what x is of here. That would be x equals u minus 2. Okay? So I would say u minus 2 plus 2, and then u minus 2 minus 4. That's going to give me something else in there that's not, in my opinion, probably not going to be for the best, okay, for you guys. So then look at this one. What would it be in terms of x? So say x equals u plus 4. So again, I'm just adding 4 to both sides, right? Adding 4 to both sides. I subtracted 2 there. U plus 4. Well, u plus 4 here would take me to u plus 6, and u plus 4 there would just take me to simply u. So to me, this one right here is the one we would want to go with. Okay? So, if I rewrote this problem like this, x plus 2 and x minus 4 to the 1/2 power, if I rewrote it like that, and I said I'm going to make this right here my u. So u is equal to x minus 4. Du of dx is equal to 1. So therefore du is equal to dx. And basically here's what I'm doing. I'm replacing dx with du. So then I'm saying x is equal to u plus 4. So here's what it looks like. The antiderivative of u plus 4 plus 2 times u plus 4 minus 4 to the 1/2 of du. Now, I would then have this then. I would have u plus 6 and u to the 1/2. And technically I can put that 1/2 in there. Now, the reason I didn't like this other way, u minus 2, because you may be saying, well, you got me lost on why you went with this over this, okay? The reason I didn't use u minus 2 is because, think here, I'd have u plus 6 times, and then that would be u minus 6 there, okay, to the 1/2 power. and I don't know how to solve. So again, if I went that other way, it would look like at this point in the step, it would look like this right here. It would look like u plus 6 over u minus 6 to the 1/2. And that makes it a little bit more difficult because then I'm going to have to go and try to figure out a u that I can multiply by to take the antiderivative of that. Okay? But here, I can actually simplify. So I can distribute before I do any kind of antiderivative. So then u times u to the 1/2 would be u to the 3/2 plus 6u to the 1/2. So I can distribute it, and then that makes it much easier for me. So then here, that would then take me, if I do that, that would be u to the 5/2. If I integrate now, take the antiderivative, u to the 5/2 over 5/2 plus 6 to the u to the 3/2 over 3/2. And then that would give me my final answer of this right here. If I plug my x minus 4 back in, okay? 1 over 5/2 will be 2 over 5. So 2/5. 1 over 5/2 is 2/5. And then u is x minus 4 to the 5/2 plus 6 over 3/2 would be 4. And then times x minus 4 to the 3/2. And all of that plus c. So again, the route you would take here when deciding between the two is just try both. Obviously, you had to inside with me knowing that this right here was the one that works. And then you wouldn't have to fight with this one near as much. So then, but this one right here would work, okay? So when deciphering between the two, try both. And again, that's what it says. If one choice of u doesn't work, then go to another one. All right. Last problem. X squared times that. So I'm going to rewrite this problem as x squared times x minus 1 to the negative 1/2. So I'm just going to bring that up. So let's try this one right here. Since this is the one I have in parentheses, let's try this one. Okay? So let's say u is equal to x minus 1. That's the one I have in parentheses, so that's what we're going to go with. All right? The derivative of u with respect to x is 1, so therefore we know du is equal to dx. So in that case, I know that I can replace this dx with du and plug whatever x is equal to. So x would be equal to 1 plus u, or u plus 1. All right. So here's how that would then work. Then substitute u plus 1 for all your x's. U plus 1 squared times u plus 1 minus 1 to the negative 1/2. And then that is equal to du. Okay? So then from there, that would give us u plus 1 squared. And then that would just simply give us u to the negative 1/2. Now, I'm going to multiply this because I've already solved it in terms of u. I've already done u substitutions, but I can multiply this out now. Okay, so let's multiply this out right here. That would give me, so let's do this. U plus 1, that would be u squared plus 2u plus 1. Then we have to multiply all that times u to the negative 1/2. Okay, so then we have u to the 2 plus negative 1/2 would just be 3/2 plus 2 plus, and then that's a power of 1 there. 1 minus 1/2 is 2u to the 1/2, and then that 1 would just change to whatever that is. So plus u to the negative 1/2. Now we can integrate. So I have u to the 5 over 2 over 5 over 2 plus 2u to the 3/2 over 3/2 plus plus 2 plus u to the 1/2 over 1/2. I think I saved just enough space right there to write this out. So it should be this. 1 divided by 5/2, or 1 divided by 5/2 is 2/5. And then u is x minus 1. Okay? X minus 1 to the 5/2. And then 2 divided by 3/2. If we were to flip that up, that would be 4/3. So plus 4/3 u, which is x minus 1 to the 3/2, and then plus, that should be 2u to the, 2, not u, change u for x minus 1 to the 1/2 plus c. And that would be my answer. All right, talk to me. How do we feel about U-substitution? So just taking our ability to take an antiderivative just a little bit further. Let me know. Thumbs up. Are we good? We got any questions? Colton's good. Carter's all right. Yeah, a little bit tedious. Good, good. Hey, if you guys need anything, know that you have my email. Email me anytime with any questions. We'll meet back here Thursday. Again, I should know more. We're having a teacher meeting tomorrow, Wednesday on Zoom, so I should know more about what the rest of what our time after spring break looks like. So, but if you guys have any questions in regard to the calculus, please let me know, and I'd be more than happy to answer those for you. If you need to do a Zoom conference or FaceTime with me sometime, please be more than happy to. If you need to talk, if you need to ask a question about calculus or anything, just hit me up. So you guys have 26 homework, and that is going to be due on Thursday. So bring it to our class at 1 o'clock on Thursday. Bring this done. I'll give you all my answers, and then we can go from there on to 27 notes. If you don't have any other questions of me, thank you so much for being here with me today. I really appreciate it. It's been 2 hours, so it means the world to me that you guys are, you guys have been given a card hand that not a lot of people have been given as seniors. So I appreciate that you're still on the grind. You guys are staying positive and you're still here. So I do appreciate it so much. Know that I love you and I appreciate you. If you need anything, let me know. You're free to be dismissed from this lecture. If you have any questions, I'll be here for just a few minutes afterwards. Thanks so much, guys. Have a good day. Yes, sir. You guys have a good one. See you, Alex.